everyone, in this tutorial for mathematics we're going to look at indices and factors, and we're going to take several objectives under this topic. We're going to start by the very basics that you should have a knowledge of based on primary school mathematics, that's if you remember. And the first thing we're going to look at underneath indices and factors is this: squares, cubes, square root, and cube roots. Okay, and I know these things going to make sense to you, but remember, when we talk about square root firstly, so let's talk about square root and just recap what that is. Remember that this is when a number is multiplied by itself, right? So if I have the number 2 cubed written out, means 2 multiplied by 2, which is equal to 4. 2 cubed now can be written as 2 to the power of 2, and know that 2 cubed means 2 to the power of 2, and when we have powers usually means that the number multiplies twice. Okay, so this is 2. If I have 3 I mean to say squared, right? So 2 squared means 2 multiplied by 2, which is equal to 4. And then we have, for another example, let's take another example. We have 5 squared is equal to 5 multiplied by 5, which is 25. Good? We can also have another example. I'll use another example, which means 6 squared, 6 by 6 is equal to 36. Good? Remember that we say that a number to the power of 2 means it is squared, which means the number is multiplied by itself twice. Okay? So that is square roots. To get the opposite of square root now, so we have 2 to the power 2 is equal to 4, but if we want to get the square number, so if you want to get back the original number, so let's say they give us 4 and this is the square root sign here. If you ever see this sign with a number, it means square root, I call this x, of number x. Okay, remember you pause the video and take down your relevant notes. So x, square root x means square root of number x. So if I have the square root of 4, then this is 2, because we know that 2 multiplied by 2 is equal to 4, or 2 squared is equal to 4. Good? Let's take another example. Let's say I have, again you should have paused the video and take that down. Let's say I have 25. The square root of 25. The square root of 25 is equal to 5, because 5 multiplied by 5 is equal to 25. Good? So this was square numbers and square roots. So now we move on to cube numbers and cube roots. So I'm going to just erase this so you could go ahead, pause the video and take your notes. Right, so now we're going on to cube roots. I always mix up square and cube when I'm just teaching and not really paying attention to what I'm saying, right? So I have now cube numbers or a number to the power of 3, and I'm using x as a number because we don't know what number it is, right? So any number to the power of 3 means a number is multiplied by itself 3 times. Okay? Example, 4 to the power of 3. Right? If I have 4 to the power of 3, it will be 4 multiplied by 4 multiplied by 4. Right? 4 by 4 is 16, and 16 by 4, if you don't have a calculator, work it out. 6 4s are 24, 1 4 is 4, 5 6, which is equal to 64. Okay? If I have 5 cubed, it means 5 multiplied by 5 multiplied by 5, which is 5 5 25, and 25 by 5 is equal to 125. Now if I have 2 cube, it means 2 multiplied by 2 multiplied by 2, which means 2 by 2 is 4 by 2 is equal to 8. Good? So this was cube numbers. However, if I want to get back the number that I cube, I need to make these across here square roots, right? Sorry, cube roots. So I would now use this symbol 3 with the square root sign like normal and then the number, which means cube root. Okay? So just like how we had the square root sign, we now have the cube root sign. So 3 with the square root sign, or cube root, this means cube root. So if I want to cube these numbers now, I just have to put the cube root sign and 64 inside, right? If you could type this into a calculator, then you're going to get it if you have a scientific calculator. But if I want to say the cube root of 64, I'm going to get back 4. If I want to say the cube root of 125, I'm going to get back 5. And if I want the cube root of 8, I'm going to get back 2. Right? And it is simple. Why we get this answer? Because again, when we say 4 cube means 4 by 4 by 4, which is 64. So now when we want to get back to what we had before, we need to cube root. Cube root 64 is 4. Cube root 125 is equal to 5. Cube root 8 is equal to 2. And I believe this was primary school maths, right? So we can now say that the number is in the cube form, which means 3. When we do square root, we means 2, right? So that's the difference between cube root and square root. So I think I just brushed through this because we should have a knowledge of this. So I hope you attend the exercises that I will be posting on it. Now we're going on to index notation. When we have index notation now, it means we have a number with a power. And remember, so let's erase all this. I want to go on to index notation. So let me clean the board and start back from scratch. So when we talk about index notation, it helps you break down long expressions, right, to something smaller for us to comprehend. Because sometimes if I have to write something like 5 to the power of 64, that could take me a whole line in your notebook, right? So we're going now and we're going to head up index notation. Okay? So you just take the note. Index notation is very useful in simplifying long multiplication facts. Okay, so let's say I have 2 multiplied by 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 2. I have this long strand here with just 2 multiplied by itself how many times, right? We can simply write this as having all the same number. It will have a base number of 2. But to simplify this now, if I check 2, I'm going to get 1, 2, 3, 4, 5, 6, 7. So I could put it to a power of 7. The number 7, this number 7 here, is not a square or cube because it is not 2 or 3. So this number is called the index or the powers, right? Or the power. So we have 2, if I could write this out in word, 2 to the power of 7 means 2 multiplied by itself 7 times, right? So just take down this note, pause the video, take down this note, and we're going to do some worked example now. Okay? And I'm going to do a couple, like 3 examples, and then we'll move on to the other part of this particular topic. So example 1, I have 3 to the 4th power. I have example 2, which is 4 to the 5th power. I have example 3, which is 7 to the 1st power, 1 power, right? So the solution for this one will be 3 to the 4th power is equal to 3 multiplied by itself 4 times because the index of the power is 4. So 3 multiplied by 3 multiplied by 3 multiplied by 3. 3 multiplied by itself 4 times will give us 81. 3 multiplied by 3 is 9. 9 by 3 is 27. 27 by 3 is 81. Okay? So this is the answer for that one. Now I have this one. 4 to the 5th power means 4 multiplied by 4 multiplied by 4 multiplied by 4 multiplied by 4. So I have 4 multiplied by itself 5 times. And this will end up to be 1024 when we finish multiplying it. Right? I think at Form 1 level you are not allowed to use a calculator, but definitely from a Form 3 level you are allowed to use a calculator. They expect you to work all of this out from scratch. So if you're Form 3, 4 and 5, you're allowed to use a scientific calculator, which makes life very easy. If you're in Form 1, you have to fight up and do it naturally, right? And then anything or any number, so this particular example here now comes with a rule. Okay, this 7 was raised to the power of 1. 7 was raised to the power of 1. So anything, so the rule states now, any number raised to a power or index of 1 means the answer will be the exact number. Okay, so 7 raised to the power of 1 means 7 multiplied by 1, which is equal to 7. Okay, so any number raised to the power of 1 is equal to the number itself. So if I had 6 to the power of 1, it will be 6 multiplied by 1, which is equal to 6. If I had 8 to the power of 1, it will be 8 multiplied by 1, which is 8. Okay, so this was the first type of work solutions, right? Now I want to add it to a fact then, so like a problem. Okay, so pause the video and take it down and erase it again. So this was type 1, you could say. I'm going now to put type 2 on the board. And type 2 deals with finding the missing powers, okay? So index notation, finding the missing powers, or missing power for that part, right? So let's say I have example 1, I have 3 to the power of 4 multiplied by 3 to the power of 6 is equal to 3 to which power, right? We need to find this. What is the power? Now, when we multiply numbers with powers and indices, remember, this is a base number, okay? So, if the base numbers are the same, we keep it. Okay, so I'm keeping my base number of 3, right? So they tell me 3 to the 4th power multiplied by 3 to the 6th number is equal to 3 to a number that we don't know. 3 and 3 is the same, so we put back 3 here, because once you have the same base number, the answer will be based on that base. But this actually means 3 multiplied by 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 3, right? 6 times. Okay? And when we break this down, we could multiply it out, yes, right? But this is just the powers we're dealing with. This is just telling me 3 is available 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then this answer here now will be 3 to the power of 10. Okay? And a simpler way to do this, instead of saying 3 to the power of 4 multiplied by 3 to the power of 6 to find 10, all we have to do is add powers. So 6, let me go with the first power. 4 plus 6 is equal to 10, which is equal to 3 to the 10th power. So we end up back with that, right? So when we have the same base numbers and we're multiplying, so we're going to take a note just to wrap up this particular question and then do another similar. So when we have a problem with the same base number and easy way to find the power or the answer power is by adding the powers of both numbers. Okay? So we have 3 to the 4th power and multiply by 3 to the 6th power, and they ask us 3. The answer will be 3 to what power? Right? Without even knowing this 3 here, you're supposed to know that once we have two same base number, the answer will be the same base number. So we need to work on the powers. Therefore, it will be 3 to the power of 4 plus 6, which is equal to 10. So we end up with 3 to the 10th power. When we have a problem with the same base numbers like this, an easy way to find the powers, the ending power or the answer power, is by adding the powers of both numbers. So we just add 6 plus 4 and we get 10. Okay? So let's do another question now. So then call this example 2. Example 2 has 4 squared multiplied by 4 cubed, which is equal to 4 and a missing number. So just from before, our base number 4 is the same, so our answer will have 4. So when base numbers are the same, we just need to add the powers. So this will be 4 squared multiplied by 4 cubed is equal to 4, 2 plus 3, which is equal to 4 to the 5th power. Okay? And if I should spread it out and multiply all, it will end up with the same, because I have 4 2 times here and 4 3 times here. So 4 by 4 by 4 by 4 by 4 will give me 4 to the 5th power, okay? So for this rule, we can wrap it up by saying any number, let's label the number a to the m power multiplied by a to the n power. So notice we have the same letter to represent the numbers, which means the numbers are the same, is equal to a to the m plus n, okay? So this was to multiply. Now when we divide, it takes a different approach. When we divide, we need to subtract. So let's look at that now. And a power could be in a negative form, okay? So let's look at that now. So division. So example 3 is a division question. Example 3. 5 to the 7th over 5 to the 4th power is equal to, both bases are the same, so we keep in our 5, right? Is equal to what? And they put a question mark there. This is simple. If I should shell this out, it means 5 multiplied by 5 multiplied by 5 multiplied by 5. Right? 5 multiplied by itself 7 times over 5 4 times. Okay? And when two numbers on the numerator and denominator of a fraction is the same, we could cancel it out. We could just take out, right? And I'm going to end up with 3, which will lead me to 5 to the 3rd power. However, if I write it out like this, 5 to the 7th power divided by 5 to the 4th power, instead of having it in fractional form, I can just say 5 to the power 7 minus 4, which is equal to 5 to the 3rd power. Okay? So we have a note for this, and I'll write it right here on the side. When bases are the same, and the base is the number, the big number at the bottom. When bases are the same and we are dividing, we subtract the powers, okay? We subtracted the powers. So we now have 5. So let's take it in the note format. So if I have a to the n power over a to the m power is equal to a to the n minus m, or I could write it like this: a to the n power divided by a to the m power is equal to a to the n minus m. Okay? So a is the unknown number. This is just like the formula, okay, to explain what we did here. So that was our example for that. And we also have a rule that anything to the power of 0 is equal to 1. Okay? So I'm going to give you that note now. So you can pause the video and take down this set of notes, and we will continue. So we have now a rule that anything raised to the power of 0 is equal to 1, and this is important for you to learn, because if even at the CXC level they put question and students put 0, because remember, anything multiplied by 0 is 0, but in powers and indices, or find an index, if I have a to the power of 0 is equal to 1. If I have 7 to the power of 0 is equal to 1. If I have 8 to the power of 0 is equal to 1. If I have 6 to the power of 0 is equal to 1. If I have 151 to the power of 0 is equal to 1. So any number raised to the power of 0 is equal to 1. Okay, and this is the formula for that. A to the power of 0 is equal to 1. Okay, so that's a rule that you must know. So again, pause the video, take it down. Okay, So we're moving on now with another type. I know I said it had two types, but now we have one with brackets, and with brackets there's a rule, okay? With brackets now, let's say we have, so pause and take down, I'm going to erase now. So let's say I have this, open brackets, a to the m or the power of m, and then this is raised to the power of n. So a to the power of m to the power of n, and they have it in brackets, right? This means a m multiplied by n. So once we have brackets involved, once there are brackets involved, we need to multiply the powers, okay? So let's look at some examples. So I have two examples. I have example A, example 1. I have 2 to the third power to the fourth power, and then I have example 2, 3 to the power of 2 to the power of 3. So this means 2 to the power of 3 multiplied by 4, 2 to the power of 12. And so we multiply the powers of 3 and 4. 3 fours are 12. So we end up with 2 to the power of 12. If I have this one now, this means 3 to the power of 2 multiplied by 3, which is equal to 3 to the 6th power. So we multiply 2 by 3 and we get 6. So you need to take down this rule. When we have brackets, the powers usually multiply. Once you have brackets involved, we need to multiply the powers, okay? So this is the formula that you need to take, and the note and the example to supplicate that. So I want you to look at the exercises for that. I am posting many exercises for you, okay? So a next rule that I want you to take, and it will come when you do your exercise, and I want to do some simplifying expressions with powers now, right? So we will look at a question with a number that there is no power. How do we work that, right? Given a number with a power. And it's easy. So let's work some questions together now. And this is how the questions usually come in the exam, whether it be CXC and the term, it do come, right? Because most likely your term exam is based on the pool of CXC questions. Most schools don't write new questions, they just use over past papers. So the first example is A multiplied by A to the power of 2. So we have A to the third power and A to the second power. So given our base numbers are the same, it will be equal to A. And given that these powers are, the A's are multiplied to each other, then we have to add powers. So it will be A to the power of 3 plus 2, which is equal to A to the 5th power. Okay? Now I'm going to look at example 2. And I have P to the power of 2 multiplied by P to the power of 7 all over P to the power of 5. Right? How would we work this one out? This is simple. How would we do it? I would work, if I was you, I would work top first and then add the bottom, right? So let's go. So P to the power of 2 is equal to P multiplied by the power, the bases are the same and the bases are multiplied, so we just add P to the power of 7 plus 2 is 9 all over P to the 5th power. So when we work this out, we get P to the power of 9 and we put back the P to the power of 5, right? Let's not write it so big. So we'll end up with now, remember this expression can be written as P to the power of 9 divided by P to the power of 5, right? Which will end up with P to the 9 minus 5 power. Remember when we divide we minus? So 9 minus 5 is equal to P to to the power of 4. 9 minus 5 is 4. Good? Now we will look at a third example, and I'll put it across on this side. And I have x to the power of 7 multiplied by x all over x to the power of 3 multiplied by x to the power of 4. Again, work line by line, okay? It's not BODMAS or anything, so we don't need to get brackets and multiplication. First, we move in to simplify, right? So the question asks to simplify. Okay? So when we take the first line, I have a note to give you. If a number has no power, it is recognized as having a power of 1. So you see this x here stands alone. We need to rewrite this question now. It will be x to the 7th power multiplied by x to the power of 1. So this number has no power here. We do not put 0, right? If you put 0, you will end up with the whole thing meaning 1, and that will change the base number. So what we need to do is keep the x and just put 1 as the power. And now we go in x to the power of 3 multiplied by x to the power of 4. We multiplying, now bases are the same, so we need to add it up, right? So we need to add our power. So it will be x to 7 plus 1 all over x to 3 plus 4. And this will lead me to have, and I'll write it in a different color, x to the 8th power all over x to the 7th power. Okay, so this is simplifying it up until this level, but we can break it down further. This means powers need to minus because we are dividing. So this now can mean x to the power of 8 divided by x to the power of 7 is equal to x to 8 minus 7, which is x to the power of 1. Right, so our answer is x to the power of 1. So you see how much steps we take? Now in your notebook, I don't want you to shove everything in one line. I need you to break them down step by step, even if you use half of a notebook page. Clarity is essential. I have students who will shove this in between one line space and then put this in the side and put this and then put this and just end up in one line, and it confuses me. What I want you to do is work it out line by line by line, okay? Don't shove everything in one line. So there's definitely exercise being posted for this, right? So now we'll continue. And now we're going to look at factors. And we all should know what a factor is by now. So you need to pause the video, take your notes, and I'm going to erase the board now so we could start with factors, okay? So let's erase. So, factors. Well, I don't have a class to talk to me here, but if I was in a class, I would ask you what is a factor. So when we talk about factors, we are speaking about a positive whole number right? So a factor of a positive whole number is a whole number that can divide without remainder or exactly into it, right? So let's list all the factors of 20. So factors of 20. So what numbers can be divided into 20 without a remainder, and no, well, obviously won't be greater than 20, right? So all the numbers between 1 and 20 that could go exactly into 20 without a remainder. And we need to brush cut this now. So the highest number is 20, and 20 could go into 20 one time, and then the lowest number is 1, and 1 can go into any number, okay? So what is the next number? Can 2 go into 20? 2 into 20 is 10, so yes. Can 3 go into 20? 3 could go into 20 6 times with 18, so we have remainder 2, so 3 is out, right? Can 4 go into 20? Yes, 4 can go into 20 5 times, so 4 is a factor. Can 5 go into 20? Yes, because 5 can go into 20 4 times. Can 6 go into 20? No, 6 could only go into 20 3 times with 18. 6 by 3 is 18, and we're going to have 2 remainder, so 6 is not a factor, right? Can 7 go into 20? No, 7 could go into 20 twice with a remainder of 6. Can 8 go into 20? No, 8 can go into 20 twice with a remainder of 4. Can 9 go into 20? No, 9 into 20 is 2. 9 into 20 is 2 with 2 remaining. And can 10 go into 20? Yes. 10 can go into 20 twice. Okay? So 10 can go into 20. 11, 12, 13, 14, 15 cannot go into 20. So the next factor that could go into 20 is 20 itself. So the factors of 20 are 1, 2, 4, 5, 10, and 20. Okay? So this is what we mean by factors of 20. Okay? So now we have this example. So I hope you paused and took this down. And they phrased it like this. Write the number 12 as the product of two factors in as many ways as possible. So write a number 12 as a product of two factors. So which two numbers or two factors that multiply by itself will give us 12. So we have first one, 1 by 12 is equal to 12. Right? 6 by 2 is equal to 12. 4 by 3 is equal to 12. 3 by 4 is equal to 12. 2 by 6 is equal to 12. And 12 by 1 is equal to 12. So from the multiplication tables, the factors that could be the product of two factors that will end up with 12 is 1 and 12 multiplied by each other will give us 12. 6 and 2, 4 and 3, 3 and 4, 2 and 6, and 12 and 1. Okay? So there's exercises for this as well. So please follow up on that. And now we're moving on to prime factors, HCF and LCM. So let's continue. So any positive whole number that can be written as a product of a number of prime factors, right? So for example, 20 is equal to 2 to the power of 2 multiplied by 5, and so forth. So what is a prime number? A prime number is a positive number or a positive whole number, right? With exactly two factors. Two factors itself and 1. Okay, so a prime number is a number that is a positive whole number with 2 factors. So only 2 numbers could divide it into this number, itself and 1. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, and so on, right? 2 could go into itself 1 time and 1 can go into 2. 3 could go into itself 1 time and 1. By the way, it can go into itself and 1. We're not talking about remainders, we're talking about exactly. 5 could go into itself 1 time and 1 can go into 5, as well as 7 and 11. Okay? So, you need to remember this little fact here, that a prime number can only be divided by itself and 1. So now we're moving on to looking at which numbers can multiply each other to give you a product of 2 prime factors, right? So let's continue. We have now the question. We have write the number 276 as a product of prime numbers. Okay, so we know we need to write 276 as a product of prime numbers. So we know that 276 is equal to 2 by 138, or 138 multiplied by 2. But from this now we can say 138 is equal to 2 multiplied by 69. Therefore, 276 is equal to 2 multiplied by 2 multiplied by 69. Right? 2 multiplied by 2 multiplied by 69 will give us 276. But 69 is equal to 3 multiplied by 23. Therefore, 276 is equal to 2 multiplied by 2 multiplied by 3 now, multiplied by 23. Okay? So this is how we write the number 276 as a product of prime numbers. So we start off with which two numbers, or which number when multiplied by 2 will give us this. Then we take that number and find out what multiplied by 2 will give us this number. And we'll add that to this equation now. So 2 multiplied by 2, the first 2 multiplied by 69 will give us 276. So now we have 69 here. So what multiplied by what will give us 69? And 3 multiplied by 23 will give us 69. So now we can say 2 multiplied by 2, so this 2 multiplied by this 2 multiplied by 3 now, multiplied by 23 will give me 276. Okay, so write the number 276 as a product of prime numbers, and all these are prime numbers. 138, sorry, 69 and 23. Okay, so we can now break this down and say 276 is equal to 2 to the power of 2 multiplied by 3 multiplied by 23. We have 2 multiplied by 2 here. This means 2 to the power of 2, and this is how we now write it. Okay? So another important concept that we need to look at is HCF, which is the highest common factor. So we'll move on to that. So pause and take your notes. So we have HCF, which means highest common factor. Okay, and if you still don't understand anything from the video, I would encourage you to raise it during our Zoom session, and I will tell you when. Okay, so fine, we have an example. So before I get into the example, highest common factor. Highest common factor is the largest number which is a factor of both or all the numbers. So if I have two numbers, let's say 120 and 105, which is the highest common factor that could be, or the number that can, the highest number that can divide into them both without a remainder, right? So the largest number which is a factor of both or all, so you can have a strand of 3 numbers or 4 the numbers. Okay, example, I have find the HCF of 120 and 105. Okay, and we're looking at which number can divide into 120 and 105 without a remainder. Okay, so we need to take this apart now. So we can say, what I like to do, 120, we start with 2. Once it's an even number, we start with 2. 2 into 120 is 60, and we can divide this by 2 again. 2 into 60 is 30. We can divide this by again. 2 into 30 is 15. What can divide by 15 to give us no remainder? We can say 3, right? 3 into 15 is 5, and then we can say 5 into 5 is 1. So we always break it down to get back 1. So the numbers are 2 by 2 by 2 by 3 by 5 to give us 120. If we multiply that, we're going to get 120. Right? Now let's do the same for 105. 105 now, divide by 2 is, we can't divide by 2 because it will end up without a remainder. So we can say 3, right? So 3 into 10 is 3, remainder 1, and this will give me 5. So now I can say 5 into 35 is equal to 7, and then I can say 7 into 7 is 1. So the answer, the factors for this one is 3 multiplied by 5 multiplied by 7. So what is the common factors between these? And it's easy to see. 3 and 5. Good? 3 and 5. So 3 multiplied by 5 is equal to 15. So the highest common factor between 120 and 105 is 15. Okay? And this is what we need to look for. The two numbers that are similar and then multiply to get that common factor. And that's the highest common factor. Okay? So let's do another example. Just like this. So pause the video, take it down. Okay? So let's erase and go again. So we have now, find the largest or highest common factor that will divide into both 660 and 470. Okay? And this is very simple. 660 and 470. So we can start by breaking it down the same exact way. So the HCF, so find the HCF of 660 multiplied by, and 470. Okay, so the two numbers we want to find the highest common factor for is 660 and 470. So we can start. So let's say 660 and 470. What can divide into 660? The smallest factor first, and we could try 2. 2 into 660 is, 2 could go into 6 3 times and 2 could go into 6 is 330. And now we can divide this now, and we could use the factor, we can use 2, actually I'll use 3. 3 into 3, 1, 3 into 3, 1, and 3 into this cannot, right? So now we could go back to use 2 now. 2 into 11 is 5, remainder 1, 2 into 10 is 5. Then we can use 5. 5 into 5, 1, 5 into 5, 1, and then we can use 11. 11 into 11 is 1, okay? So our numbers here is 2 by 3 by 2 by 5 by 11. So let's take apart this one now. I can use 2. 2 into 4 is 2. 2 into 7 is 3, remainder 1. 2 into 10 is 5. Then I can probably use, what can we use now? What can go into 235 without having a remainder? Right? So this is what we need to go and find now. This might be a little difficult. Think about it. 2 into 2, 1. 2 into 3, 1. And then we have a remainder of 15. With 1, make it 15, and 2 cannot go into that. So let's try 3. 3 cannot go into 2. 3 could go into 23, 1, but 3 cannot go into 25. So let's try 5. 5 into 20, yes, 5 will go in. 5 into 23 is 5 with 3 remainder, and 5 into 35 is 7. And then we have, what can go into 57 now without a remainder? And the thing is, 57 is a prime number, so 57 into 57 is equal to 1. So we end up here with 2 multiplied by 5 multiplied by 57. So what is common between this? And we have 2 multiplied by 5, right? And therefore, 2 multiplied by 5 is equal to 10. So the HCF of 660 and 470 is equal to 10. Okay? The two highest common factor is these two. And when you multiply them, we get 10. So you can look at that as well. Now we're looking at LCM. And LCM is what we did in primary school, if some of you did it in primary school. So let's look at that quickly. So LCM now. And LCM is the lowest common multiple. So the lowest common factor. Right? So LCM. Lowest common multiple. Okay? So what is the LCM of two digits now? So the LCM, for example, find the LCM of 24 and 60. So this is easy. So we need to find the factors of both numbers. So the first thing we do, find factors, right? Or multiples then. So the multiple, find multiples. And multiples is basically the number that when we multiply it, we get back, when we multiply 24 by a number, what are we going to get? So 24 by 1, 1 by 24 is equal to 24, 2 by 24 is equal to 48, 3 by 24 is equal to 72, 4 by 24 is equal to 96, 5 by 24 is equal to 120, right? I'll stop here a little bit because I want to make sure I don't surpass what I want to do. So now let's say 1 by 60 now is equal to 60, 2 by 60 is equal to 120. So if we continue here, 6 by 24 will give me 144. But the lowest common multiple between both numbers is 120, right? Because it's basically the first common factor we reach in both, and this was 120. So the LCM of 24 and 60 is equal to 120. by finding multiples, and multiples is basically the multiplication tables of these numbers. Okay, so now we're moving on. We have further index notations to look at, and what I want is to look at the formulas first, or how it is written based on expression, and then do the worked examples with you. So again, I hope you pause and take the relevant notes down. Okay? So let's continue. So just head up now, further index notation. This is the last part of this lesson, further index notation. Okay, and we have a to the inverse, or a negative 1, which means 1 over a. This means reciprocal of a. Okay, and then we have a to the negative n, which means 1 over a n. And then we have a to the half, or power of half, which is equal to the square root of a. And then we have a to 1n, which is the nth root, right? So n could be any number, so the nth root of a. And this is we will need a calculator for. So let's do some worked examples now. And the first one I have is 2. So let's do the examples on this side here. So example 1, we have 2 to the negative 4 power, right? This will follow this rule here. So it will be 1 over 2 to the 4th power, which is equal to 1 over 2 multiplied by 2 multiplied by 2 multiplied by 2, which is equal to 1 over 16. Okay? So this is the first example. So we have 2 to the negative 4, which means 1 over 2 to the 4th, which means 1 over 2 multiplied by 2 multiplied by 2 multiplied by 2, which is equal to 1 over 16. Example 2 now. We have 5 to the power of 1. This means, following this rule now, it will be 1 over 5, and this is your answer. Then we have a third example, which is 8 to the power of a third, and this will follow this rule, and it will be the cube root of 8, which is equal to 2. Okay? And then we have a fourth example, which will follow this rule, and it will be 9 to the 3 over 2 power. The marker not allowed me to write small, right? So we'll end up with 9, and this is a half, but this half is multiplied by 3. Okay? So we'll end up with now, remember when we have brackets like this, we need to multiply the power. So it will be 9 to the half multiplied by 3, which will be to the base number. Now we'll end up with 3 cube, which is equal to 3 multiplied by 3 multiplied by 3, which is equal to 27. Okay? So this is the next part of it, and I'll go over each one individually. So we have 2 to the minus 4 power, which means 1 over 2 to the 4th power, which means 1 over 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 1 over 16. Then we have 5 to the minus 1 power, which means 1/5. Then we have 8 to the 1/3 power, which means 8 to the cube root. And then we have 9 to the 3 over 2 power, which is a fraction. And this means a half, 9.5 power in brackets multiplied by 3 to the 3rd power. So there's a note I want you to look back on when we do that particular one, and it was in the previous part when we did indices. And it basically tells us to multiply this, right? But what they did here now is they just look at half of 9. Well, they pull back a common base, which is 3, and 3 to the third power. Right? What are two factors to multiply by 9 is 3 by 3 is 9. So they put 9 to the third, 3 to the third power, which will equal to 27. Okay? So now we move on now. So you can pause the video and take down this note, and we will continue. Okay? So let's look at what we did before, but we now have negative bases on it, right? And this will require us to use directed numbers. So, examples, we're looking at some questions. Example 1, 2 to the minus 5 power multiplied by 2 to the 6. Remember, when we have two similar bases and they multiply to each other, the numbers will add. So it will be 2 to the minus 5 plus 6. And remember, when we taught directed numbers, I drew the number line. So minus 5 plus 6. So now in primary school now, so I'll touch on directed numbers here. You draw a number line 1 to a number. In secondary school now, we need to draw a number line with the base or the middle being 0. And when we expand to our right, we have positive, and when we go to our left, we have the negative number. So we now have 1, 2, 3, 4, 5, 6, 7. And then we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So the question is minus 5 plus 6. Remember in standard 1 when we did number line, they told us that when we add on a number line, we move to our right. So when we add, we move right. Okay? So minus 5 adds 6. On your number line now, we're going to locate minus 5, and this is this right here. And to this, we're going to add 6. So we're going to jump 6 spaces to our right. So we're going 1, 2, 3, 4, 5, 6. We're going to end up with 1. So this will mean minus 5 plus 6 is equal to 1. So for this question, 2 to the power of minus 5 plus 6, we're going to go 2 to the power of 1. Good? So that wasn't too bad. And now we have the next question. So pause the video, take the notes. Number 2 now, have this question. M to the second power multiplied by 4 to the minus 4 power. Sorry, m to the minus 4 power. So we have two bases, so it will be, and they multiply, it will be two numbers add. So 2 add minus 4. And this is simple. When we have two signs, a plus and a negative, we need two signs make a negative number, right? Two differences make a negative, which will mean is equal to m to the power of 2 minus 4. These two signs up here, a plus and a minus, or multiply by, remember brackets mean multiply, right? So a plus multiplied by a negative will give me negative. Negative multiplied by a plus will give me a negative. A plus multiplied by a plus number will give me a positive, and two negatives will give me a negative or a positive number. In this case, we have plus multiplied by minus, so we're going to get negative, right? Plus multiplied by minus, negative. So now we're going to get 2 minus 4, and I know some of you saying, but 2 cannot take away 4. If we draw one number line back with positive and negative figures, 2 could minus 4, and if you plug it onto a calculator, you'll be able to get it too. Okay? right? So we have the number 2 here, and remember when we minus on the number line, we move in left, right? So we find 2 and then we jump in 4 space back. 2 minus 4. 1, 2, 3, 4. We're going to end up with m to the power of negative 2. 2 minus 4 will leave me by negative 2. Okay? So 2 minus 4 is equal to negative 2. So this is my answer here. And this is the same format that you need to work on right through. Okay? So I will post these questions for you to work with, and I hope you had fun learning this particular topic. Some questions is a little trick, but I want you to try and work it out on your own to see if you can apply all the different rules that we learn and apply to the question to see if you could figure it out for yourself, because it's really that common sense. Okay? And if you don't get through, we will look at it during our Zoom sessions. And this topic is Form 1 work, okay? So I want you to really appreciate it. Pause the video and take your notes and understand all the different examples that we do. Any clearing up that you have, take a note of it. If it's urgent and it depends on you doing your work, then you can message me. If not, I want you to I need you to go and make a note of it, and we will go them over during our Zoom session, so you'd have a better understanding of it, right? So thank you for watching this video tutorial on indices and factors.